And thank you all for the invite and opportunity to share some information and also hear a little bit about what you guys are doing. I'm going to talk mostly about trees today. Forest principles will apply to any plants or presumably even other organisms. The first slide is the title slide, and it's talking about developing durable resistance, something beyond what sometimes is done in some segments of agriculture. And trees are long-lived organisms. Genetics are the baseline that protect both humans and other organisms against diseases and other changes. On the cover slide, you see white pine blister rust on a tree on the left side, and then Phytophthora lateralis killing porterfoot cedar on the right side. So how do I advance the slide? Oh, wait. Okay, so what are those threats? Non-native insect and disease problems. They certainly increase public awareness that some tree species can become extinct or very rare in a small period of time. They can lead to major changes in our forest ecosystem, as with chestnut back east and white pine blister rust out here and Dutch elm disease, et cetera, can lead to serious economic losses in managed forest plantings. And then with a changing climate, they can be, aggravated even further. So a lot going on. We are under invasion by pathogens and insects, as well as, native plants, et cetera. And I deal mainly with the insect and disease aspect. And you all know that this is happening in all across the United States, all across the world. And, I'm sure we're not done with new invaders. Every year it seems like we hear some new ones in some part of the United States. The Forest Service has a long track record dating back at least to the 40s in terms of resistance. And they've set up some centers such as ours, or very few centers such as ours that have been there now. This will be the 50th anniversary. And we're involved in developing resistance at an applied level, not a research level. And so really, if you have a problem like this and if resistance is part of the solution, who are you going to call? And usually the USDA Forest Service, the Genetics, the Forest Health Group, and their partners, whether they're universities, state agencies, other organizations, to look for a solution. Okay, so Dutch elm disease in an urban setting, the landscape changed dramatically when that came in, and so we're all aware of various examples that we can cite. So fundamentally it comes down to, will there always be trees? Will there always be forests? Will there always be your favorite tree species? And how can we help? So saving the forest, if we sit around and do nothing, someday we may wake up and find in some of our environments we don't have the trees that we like, or we don't have the forest that we like. So certainly you guys are on the right path. Number one, exclude new pests and pathogens or new invasive plants. Number one, that should get extremely high priority. Once they're in here, confine the spread or eradicate if we can. Biocontrol in some cases comes into play. With trees, silvicultural management comes into play, good silvicultural management. There's some areas where you can be proactive strategy once if something happens before there's a big impact to the ecosystem. And there's a paper that myself and Anna Shuttle wrote a number of years ago and some follow-ups to that if you're more interested in that. And then harness the genetic resistance that is available within a species and then use that for restoration or reforestation as needed. And that's mainly what I'm going to focus on. Again, genetic variation is the keystone of forest health. All species pretty much have an element of genetic variation. Some of them have a lot of genetic variation into them. And even though a lot of these species have not co-evolved with these new pathogens or insects that come in many cases there is at least a little bit of resistance at different levels. And that's what we're seeking to find and then to harness and to use. And I'm talking, in my case, I'm talking about traditional resistance and breeding, not, genetic engineering, genetic modification. That could be another example that in some cases could potentially be used as well too. But the examples I'm going to talk about are all dealing with classical breeding and genetics. So DURENA is a U.S. Forest Service entity. Lead role in development of applied resistance. We're not a research unit. We don't leave it in the research sector. It's not successful unless we get it out to the ground. We work closely with a lot of partners, mostly in Oregon and Washington, but actually all throughout the West and Canada. We just set up an agreement yesterday with Canada to do some screening work for them. And we work with all types of resistance. Sometimes in crop species, they look for what I call the easy type of resistance and the very dramatic type of resistance, but it doesn't always prove to be durable resistance. I tell people with tree species, the resistance has to last at least 100 years. And really, that's not true. It really has to last forever. You know, it has to be the last. So those trees that we put out will be the progenitors of the next generations, and that nature can. We want to raise the reestablish an equilibrium. We will never get rid of most of these insects and diseases that came in. We just want to rebalance the equation a little bit so that our tree species can continue to evolve under these new circumstances. So we seek to facilitate the development of resistance in a usable form. This is just a photo of Dorina, an aerial photo, and then a photo of some of our blister rust resistance screening. We probably have the largest inoculation chamber in the world, so for what we do, we can really carry it out on a large scale. This slide is a key one in probably any type of work, but certainly in resistance work, you have a research phase. You have kind of an applied tree improvement phase. You have a reforestation restoration phase. And it's only when the three of those come together that you have success. If things stay in research, and sometimes they do, I don't consider that successful. If things stay at my facility and we develop fantastic resistance, we have genetic variability, we have everything else, but nobody's using it, then it's really not successful either. So really, there's a lot of things that come into play, and this is a thing to keep in mind as you talk to anybody. And you know, if you talk to some researchers and they're going after some funding, that's fine, but are they later tied in with an applied product that comes out, or will there be an application for it? So the solution to some of these problems at certain stages is genetic resistance. It's the grain is a natural solution. All organisms have genetic resistance to a degree. There's different types of resistance that we may be able to uncover. What level is needed? What level is achievable? How are those correlated with other adaptive traits? And is the resistance durable? It's no good if we have some types of resistance that we found in white pine blister rust that on some sites only lasted 5 or 10 years. So obviously that's not going to do us a whole lot of good. So the strategy, we look for all types of resistance at one time, major gene resistance, which oftentimes is what they deal with in crop species, as well as partial resistance, which is much more difficult to find. But at the same time, we're not looking to put out one cultivar, maybe for a city or urban case, but even in that case, I would encourage you to value genetic variability as well as maintaining adaptability. So in our cases, we're looking at developing populations with resistance, not one or two clones with resistance. So we want to maintain, we think there will be other threats in the future. We think that these species need genetic variability, certainly in our forests, but I would even argue in our urban forests, we need a certain amount of genetic variability there to stop problems in the future. Porterford cedar is both a horticultural species planted in cities and urban areas around the world, and especially in the U.S. It is native to Oregon and California. It can be several hundred years old, but a phytophthora, a root disease, came in that can kill big trees and small trees. And fortunately, there were a few lawsuits. Long story short, both the Bureau of Land Management and Forest Service got involved in looking at ways that they could mitigate the problem, and they set up some management things in the forest, but then they also started a resistance program. And I was part of the start of that resistance program back in the early 90s at our facility. And really, you're going from left to around clockwise on the screen. You have large trees in the forest. You have a disease that comes in, so you have a problem. The solution in this case, you can't get rid of the disease. In some cases, you can keep it from spreading to other areas by road closures during certain seasons, et cetera, too. But that's not going to get rid of it or reestablish those areas where it's impacted your forest. So fortunately, we found some resistance in the species. Fortunately, this species is almost like a crop species. You can do a lot with the species, so we can move it very fast. It's probably one of the fastest moving resistance programs for a forest tree species in the world. Various reasons, both the people involved with a passion in the field, our center, but also the biology of the species. And so we develop resistance, we get seed out there, but then, like say, to have success, somebody has to plant it. And the slide in the bottom left shows a volunteer group planting along a river, and there, I think, volunteer group are a couple groups of people who are involved in fishing, and the fishermen, and they want to keep the salmon and the other fish healthy and the temperature streams cool and whatever too. And portable cedar is an invaluable species along the streams. Now, in terms of resistance, resistance is not immunity. What these two slides are showing real quickly are the two types of resistance. The red line at the top of both graphs, this is percent mortality. The red line is the normal susceptible progeny of a susceptible parent. It goes to 100% mortality in our greenhouse trial very, very quickly. On the graph on the left, we have one family where you see a yellow line going across the bottom. There's no mortality in that family even after 3 years in the greenhouse. Good news, there's resistance. That's major gene resistance. On the other graph, you see the red line at the top, 100% mortality, and you see some other families that within these families, a family is seed off of one parent tree, so these are seed off of different parent trees, and there's like 42 seedlings per family, and you can see some of these families have some mortality. Each of those dots is the percentage mortality within the family, but a lot of those families never go to 100% mortality, so even after 3 years, they have some individuals in the family that either die slower or have not died, and so we hope to capture both those types of resistance, incorporate those into seed orchards, produce seed, and get that back out for the landowners. And again, this is the case where, you know, there was a fisheries biologist that enlisted the group with some volunteer groups, and they planted along a river down in southern Oregon. And so restoration part is very, very important. Whitebark pine, if you visit the west, Yellowstone or Crater Lake National Park in Oregon, the high altitude species, whitebark pine, it was proposed for listing under the Endangered Species Act. It was, by the Fish and Wildlife group, it was found to be warranted but precluded because of limited budget, and they had a bunch of species in line before whitebark pine. So the Forest Service and partners, some of the tribes, the BLM, national parks have taken on some effort, even before this listing started, to look to see if there's resistance. White pine blisterus is knocking out, there's 9 species of white pines in the U.S., and white pine blisterus is knocking out a lot of populations of these white pines. So is there a resistance? You know, when we first started working with whitebark pine, and we work with 7 other species of white pines too. When we first started working with white pines, the dogma was whitebark pine is the most susceptible, has the less resistance of any of the species. And that was based on just some field observations many, many years ago, decades ago. And what we're finding is you got to watch how you make that statement. It is true that the most susceptible whitebark pine is probably more susceptible and die faster than maybe the other species, but we're actually finding much more high levels of resistance in whitebark pine than we have ever found in western white pine or sugar pine, or even a little bit of work we've done with eastern white pine. And what this graph shows is, again, it's percent of trees or seedlings in a family that are infected with a canker. And at the top, there's some families that go to 100% cankering. And then you can see some of these other families, the percentage, you know, down at the bottom, there's one family, I think it's a Crater Lake family, that only about 20% of the seedlings in that family in a very heavy seedling inoculation trial ever got stem symptoms at this point in time. So the good news is there's a large range of variability. What we're also finding is this varies geographically. In some areas of the range of the species, there's much more resistance than there appears to be in other parts of the range. So the other thing you got to watch out with resistance, if somebody makes an absolute statement, you know, it may or may not apply throughout the range of the species. And the other thing we need to follow up with this, and we have with some of our other species, is to put field trials in and confirm that this type of resistance on young seedlings also conveys to the field. Again, genetics in action. On the left, you have Crater Lake National Park. You have some whitebark pine, kind of an iconic keystone species there. You have a problem developing where a lot of the trees are dying across the range, both in Canada as well as the U.S. The bottom slide there shows these are 10 tree seedling family rows of different families going across, and you can see there's the second row up from the bottom in the right-hand corner. You have a row of green trees, and the bottom row is almost all red trees. So you have a great difference in the inoculation trial. Very, very dramatic. We have a statistician on staff, and I say, Doug, I don't need you for this. I can tell that, you know, that one family is better than the other family. So sometimes you get lucky and you get this very dramatic resistance. The slide right above that shows some people at Crater Lake in a lift truck collecting cones from the trees. So several of the national parks are very engaged with us in terms of wanting to get into restoration. And if you were to visit Crater Lake, on the far left, we have some of our technicians planting some of the resistant material at Crater Lake as a restoration trial where the park will put it out the way that they want, but each seedling is labeled so we can follow to see how that seedling family did in terms of resistance over time, and we can learn whether the resistance is durable and how it varies by family and stuff. Again, this is, Crater Lake National Park. If you go there, there used to be a parking lot that they restored, and they put some whitebark pine in. The parking lot was right in front of the lake, and they finally figured they should move the parking lot behind the buildings and have a restoration effort in front. So this was started just a couple of years ago. But it's probably, for whitebark pine, the best restoration planting that anybody has anywhere. It's also ADA accessible because of the way it was set up with these paths. So it's really neat from the point of view that it will show restoration. It will also be a genetic trial. It's probably the only genetic trial for disease resistance that's ADA accessible in the world. You know, so it will be potentially a real showpiece where 300,000, 400,000, 500,000 people a year pretty much visit this part of the park. So again, getting the news out to and having public support is really important. So there's an urgency with some of these species. If we wait too long to do something, there may not be a lot of genetic variability left in the species, or you may have something else happen. One thing that's happened in whitebark pine, we've been involved with whitebark pine and blister rust resistance since, I don't know, maybe about 2000 or 2002, maybe a little bit earlier than that. And we found some resistance trees at Crater Lake National Park, and then they're collecting more seed of that, and that's going back out for restoration. But already 25% of the trees that we found to be resistant at Crater Lake National Park have died from another problem. They died from mountain pine beetle. And so, you know, so it's not a solution just to say, hey, let nature take its course. You also have to be actively involved and look at these other threats. You know, there is potential in some areas where the mountain pine beetle would come through and it could have killed all your trees. And if you had not collected seed or had gene conservation efforts, you would be left with, hey, the good news is we found resistance. The bad news is, you know, something else killed the resistant trees, and we don't have any seedlings to plant. But in the resistance effort, you know, a sense of urgency, certainly public support. These things are usually long-term, and that can be anywhere from 10 years to 50 years or whatever. You know, you always have a few people with passion to do a lot of the work in the field. Teamwork is real important, and certainly the vision of where you want to go. And then I think also it pays to be a little bit cynical, both about your own program to make sure you're not overselling it, and also about other programs too. And you know, I've seen a lot in my time, and some programs are stronger and better and do a better job at that than the others too. The ones at Dorena, the Forest Service and some of the partners, we've been funded for 50 years, both during the period of time where in the National Forest we're more into harvesting, and so maybe a more commercial type thing, to more when it was more into ecosystem management and whatever too. So the Forest Service, even on a worldwide scale, has probably got a couple programs that lead the world in the resistance developing, because continuity is very, very important. You can't start these programs, have them on for 3 years, turn them off for a couple of years, and start them back up. One, you won't make any progress. Secondly, you won't have the infrastructure, and you won't have the personnel to make it happen. Just like any other good program, there needs to be some continuity. So thoughts and questions. Resistance can be very rare, let's admit that. Durable resistance, you know, by definition, that's really hard to say what it is until, you know, you develop it and you put it out in the field and you see if it lasts, because the pathogen or the insect also has a capability for evolving too. We certainly need to do a better job at publicizing success stories. You see very few of them that are done very, very well, and the information out there. But if you're not going to use resistance, what is the alternative? You know, in some cases there isn't. I see a lot of money going for monitoring. Monitoring is important, but I also see some programs where monitoring becomes an end-all. And, you know, I've seen some programs where I think they're going to monitor it down until the last tree dies. And they're going to say, well, yeah, and we can show you graphs when all the trees died. Well, if they had spent some of the money maybe looking for a solution or developing resistance, maybe all the trees wouldn't have died. So I just hope in the scheme of things, resistance sometimes is left off the plate or is an afterthought. And so I think we need to be more proactive in that. So we need to envision the future. How do we want to shape the future for society? Do we want to do nothing or do we want to do something? And we have to realize genetics really is the key. You know, whether it's human health, whether it's forest health, whether it's tree health, plant health, animal health, genetics is a big component of it. And we can have a dying forest or we can have a healthy forest, and genetics and resistance is a big part of that. So applied resistance programs benefit. You know, sometimes they're feasible for some species. They're solution-oriented. You can get public support usually. They're a tool. They're not, you know, they don't cure everything. They're a green solution. They can be long-term. They can have an uncertain outcome. They're not inexpensive. So, you know, it's good to realize all that going into it. There's proceedings out there, several of them, where we brought researchers in from around the world. This one was in Eugene, where I live, and brought them all together to talk about a lot of the insect and disease problems and developing resistance. Okay, back east, what programs are going on? And I'm not going to go much in detail on this, but I'm going to show some names here. So beech bark disease, emerald ash borer, Jennifer Cook is a key player there. And I would encourage you, if you're interested in those or actually any of these other species, she'll give you some good feedback. Butternut, you have several names listed there. Hemlock woolly, adelgid, I'm going to show another slide in a minute, but there's some information there. American elm, there's some work going on. American chestnut, there's some work going on. Black walnut, thousand canker disease, some work going on. White pine blister rust with eastern white pine, there's some work going on. And red bay down, Jason Smith down at the University of Florida is a key person in that. So beech bark disease resistance, Jennifer Cook is heavily involved in that. This is a little bit an overview of the program. But notice down that this is her slide, and then the next couple of slides are hers. The gap is a lack of infrastructure and funding for continued production and planting of resistant seedlings and development of new seed orchards. So she's a researcher and in research phase, and I think they found some good product to put out there, but they need people at the other end, both to put the applied part to it and then to plant it out there, because her role is not to do all of that the way things are set up. So the good news, beech bark disease, if you're interested in that, there's some resistance work. Jennifer would be the one to talk to, but there are some gaps that she alludes to down at the bottom there. Emerald ash borer resistant North American species, again, Jennifer would be one to talk to, both traditional breeding or the hybrid breeding, so I'm not going to go into detail on any of that. I'm just going to mention she'd be a key person to talk to. Resistance has been confirmed. Again, this is her slide. There's some surviving green ash that they're looking at, and then there's some hybrids as well, too. So, again, back east, a lot of good effort going on. Hemlock woolly adelgid, Robert Jetton at North Carolina State sent me some slides yesterday, and I put them together in a composite to show kind of the range of the species affected. They've done a lot of gene conservation work, so before a lot of the hemlocks are killed, they've collected seed. They're planting those out in some orchards and various other places. There's some research level work going on to study and see if there is resistance. And then the next step, if there is, and this paper would give kind of an overview of that, the next step would be, okay, is there resistance? How do we harness it? How do we use it? How do we get it back out in the forest? And that's where all of you come into play in terms of linking up with these people and asking those questions. Immediate need, one of the things that's happening, forest genetics had its heyday in the 60s, 70s, and probably the 80s. And there's a concern now between retirements and changing budgets that things are fading away. You're having key people retire. A lot of the universities have dropped out of the forest genetics realm. So you're losing the gap. This is a slide that Jennifer put together. Forest Service genetics and breeding capacity has been declining in the last 30 years, especially in the east, Midwest, Rocky Mountain regions. less so in the South and Pacific Northwest. So you could have a case before too long with a couple key retirements where even you say, okay, well, yeah, we're going to develop a resistance. Well, okay, well, who do we go to? Who's still around? What infrastructure is there? So this is the type of thing that if there is a need, I had a turf yesterday at our facility, somebody from the Washington office, and at the end I said, you know, I have some information for you. You said, well, yeah, you probably want to know about budget and more money. I said, no. So the Forest Service has to decide whether they want to have the capacity to do this type of a program. And that's all for the, you know, the citizens of the U.S. and the taxpayers and whatever to decide. Do we want to have trees, and do we want to be solution-oriented where we take on resistance and realize in some cases it's long-term, in some cases it probably won't work out, et cetera, too. And if so, then we maybe don't want to give up the infrastructure because there's always competing battles for funds, and then with key retirements and people not being replaced, you know, we really could lose the capacity to do this type of work. Over in Scotland and Europe, they have a lot of problems as well with invasive insects or pathogens. I was invited to go over to Scotland after the France meeting, and they're larch. They plant a lot of larch, but 99% of the Japanese larch is all being killed by a Phytophthora ramorum, which is, some of you might know, is sudden oak death, but it also kills larch over there. And so they're deciding what they're going to do, and they're going to look and see if they can look for resistance. And then I have a couple other slides after this, but acknowledgement, the U.S. Forest Service for funding, a lot of partners, some slides from Jennifer Cook. And then, you know, there's some new technologies that are coming out. Some people at Ohio State University are working with us, and they have some technology they want to try. We have some defined resistance programs with good products that can test the technology. And basically, I keep kidding Enrico Bonello at Ohio State University. I keep saying, no, what you're trying to develop is a tricorder. He hates me saying that. And he probably hate the slide since I have a Star Trek reference in there. But essentially what they want to develop is, right now, they can take some stuff to the lab that we have, and they can develop a chemical fingerprint for essentially resistant versus non-resistant trees that works pretty good, they think. And what they want to do is not to have to take it to the lab at the university, but develop a handheld device that you can go to the field. And once you have some resistance defined, you calibrate this device, and then you go to the field and you find other trees that are resistant. So this would fast track or shortcut or make less expensive resistance programs like ours. So there are some new technologies that are being developed that can help there. Future threats, when I was over in Scotland, there are native juniper species. They don't have that many native tree species, but they're native juniper species. There's a new Phytophthora, Astrocedri, that is hammering that. They don't know if there's any resistance. They're just starting to look at this. So, you know, we always got, if we know that this, over there, this has killed a few cedars as well, too. So I think that's my last slide. So the take-home message really is resistance is one tool in the toolbox. It is a tool that sometimes many people don't think about, or maybe until it's too late, but it can be a very, very valuable tool. There's a lot of people around, a lot of people that we're networking with in Oregon and Washington and British Columbia, Alberta, or whatever, too, that we're working together on some of these things. So I went through all of this very quickly to try to cover a lot. So I'll take any questions.